this is Mr. Coates, and this is APES lecture number 24 on non-renewable energy. If you remember in the last lecture we talked about where the energy comes from, and in the United States, unfortunately, most of our energy comes from non-renewable sources, and that's the same for the world. However, the United States is far behind some of the other countries in obtaining renewable energy sources. So for this part of the lecture, we're going to talk about just the non-renewable energy. So when we talk about non-renewable energy, we're talking about energy resources that come from the ground typically. So in the order of like oil, natural gas, coal, and then of course uranium. A lot of people don't think that nuclear is non-renewable, but it actually is, and so we'll talk about that. So as I said, most of these things come from under the ground. So we have coal trapped underneath. Remember, coal is long dead organisms. Same thing goes with oil. And so these things are trapped in the earth and we have to mine them or drill them out. And the same thing goes with uranium. So the fossil fuels, the biggest part of our energy here in the United States, basically, if we remember right, fossil fuels originate from the decay of long ago plants. So on the planet for millions of years, we were covered in lots of swamps and plants grew fairly prolifically. And then something changed and those plants died, they became buried, and over long periods of time with pressure and heat, those became our fossil fuels like oil and coal and natural gas. And so the carbon that was locked up in those plants from photosynthesis gradually changed chemical form into the hydrocarbons that we see today. One of the hydrocarbons that we use in our fossil fuels here are natural gas. Natural gas is mostly methane, which is CH4. Some of it is propane, and some of it is ethane. But most of it is methane that we get, and this is the same kind of gas that we use in our lab here in school. Now, other hydrocarbons are liquid ones, primarily oil or crude oil in this case. Whenever we take oil to the ground, we can't use that oil directly. We actually have to treat it, and we call that distillation, and we'll see what that's all about a little bit later. And then the solid type of fossil fuel is, of course, coal. And coal is a solid mixture of carbons and hydrogens with a bunch of other chemicals in it. But usually the hydrogen-carbon ratio is 1:1. So you have these long chains of carbons and hydrogens all bonded together to form a solid mass. Now, there are a lot of problems with fossil fuels, and I'm sure you guys know a lot of them. The first is it's non-renewable. We cannot get these fossil fuels back. It takes millions of years to create fossil fuels. And there's no way we can create more oil, there's no way we can create more coal, and so we are stuck with a finite amount of those resources on the planet, and we keep on using them at an alarming rate. And eventually, and I don't know when it's going to happen, and there have been several predictions that haven't panned out, but eventually we will run out of this resource, and we're going to have to find something else. There are things that are happening to help us out with that, but it's kind of slow at this point. Now, there's other problems, pollution, air pollution specifically. There are a lot of impurities. I mentioned that coal is made up of a whole bunch of other chemicals besides carbon and hydrogen. Well, when you burn those chemicals are released into the atmosphere and they cause a lot of problems. One of the biggest here is sulfur. When we burn coal and oil and diesel in our factories and in our vehicles, we release this sulfur to the atmosphere, and this can cause acid rain. That's a huge problem there. Also, sulfur is another greenhouse gas, just like CO2. So speaking of CO2, CO2 is a huge greenhouse gas. It affects the greenhouse effect, and anytime we add more CO2 or more SO2 to the atmosphere, that means the greenhouse effect can increase. And this contributes to climate change. So when we burn these fossil fuels, all these pollutants get into the atmosphere. Now let's look at our CO2 issues here, and because this is going to become more important when we talk about climate change a little bit later. So we have this graph down here, and let me change color pen real quick. And so we have the different types of electricity that are produced from different means. And what they did is that they took the amount of CO2 that is produced by obtaining that type of energy and compared it to just coal by itself. So if we were to burn coal just to get the heat from it, we're going to produce 100% of the CO2. Now, when we burn other things like synthetic oil, so synthetic oil is produced from coal, and we'll talk about that a little bit later. But if we burn that to produce natural gas, then 150% more of the CO2 is released than from just coal itself. And then if we produce electricity from this coal, then 286% more CO2 than just burning the coal by itself is produced through making electricity. So we're putting out way more CO2 by using coal to make electricity. Now, if we just burn oil by itself, we get a little bit less CO2 out. If we burn natural gas by itself, which is by far the best fossil fuel here, we get less CO2. Nuclear power, in the production of the nuclear ore, there is some CO2 release, and so it's not as much, but 17% CO2 is produced through nuclear power, compared to if we just burned coal to get the heat out of it. And so right now we are using the worst case scenario when it comes to production of CO2 to make our electricity, where if we made electricity from natural gas or from solar, we would be doing a lot better on the CO2 production. This gets us into our last fossil fuel, nuclear energy. This is a picture of a nuclear energy plant. A lot of people think that this is the reactor. This is actually a cooling tower, and we'll get into how that works a little bit later. But you see these on coal-fired plants as well. The actual reactors are in these things here. So this is the actual reactor. There's actually two reactors here. And so just because you see one of these doesn't mean it's a nuclear power plant. And it produces energy very similar to that of a coal-fired plant, and we'll get into how that works a little bit later. But it has a generator, it has a turbine, and so the only difference is how the heat is produced. So let's look at nuclear energy. Who uses nuclear energy in the world? Well, we do, of course. We are the most advanced nation when it comes to nuclear energy production. We produce a lot of, this is terawatt hours up here, so we produce a lot of energy using nuclear. We have quite a few nuclear plants here in the United States. After us, then France is next, and France produces quite a lot of nuclear energy as well, and then it really drops off. And so there's not a whole lot of countries out there that use nuclear energy, and we're starting to get afraid of some of these others up here, like Iran down here, Czech Republic. This is probably concerned to us, even though they're a democratic country. They're in a very rough area of the world. So we're worried about some of these countries getting nuclear energy. Let's look at the timeline of nuclear energy use in the world. Basically, it shows that over time, since the 1960s, the amount of nuclear reactors have really increased. And so had an exponential increase. However, starting in 1989, around in this area, we started leveling off. And the reason for this is because of nuclear accidents that had happened around the world. And so we'll get into those accidents a little bit later. But actually, you can see here that it's projected that nuclear energy will actually precipitously drop off. And there's a couple of reasons because of that, not just accidents, but some other things that are happening. So we may be at the end of nuclear energy here in the world at this point. So what are some of the problems? Obviously, the first problem is waste. When we use nuclear reactors, there is a fair amount of nuclear waste that is created. And this waste is often radioactive for tens of thousands of years. Can you imagine trying to plan how you're going to dispose of this waste for tens of thousands of years when a human only lives maybe 100 years? So we have to plan on how we're going to store this waste, what's going to happen to it once we're gone and dead. And so it's a very daunting thing to do. And what do you do with all this waste that starts to pile up if we continue to use nuclear energy? The other problem is low net energy. The amount of energy it takes to mine the uranium and enrich the uranium and get the uranium to the reactor is very high. And so when you factor in all the energy use needed to get the uranium in the first place, you get a very low net energy yield from nuclear. Accidents, I mentioned that before. This picture shows the remains of the Chernobyl reactor in Russia, actually in Ukraine, that happened, and we'll talk about some of those accidents that have happened in nuclear reactors. But nuclear accidents can be very problematic. And then the last thing that we're really worried about, especially since the attacks in 2001 on the United States, is terrorism. We do not want terrorists to get a hold of nuclear material. And so because of this, nuclear energy has really started to drop off because we were very afraid that there's going to be some kind of terrorist act using nuclear waste of some sort. And so these are some of the problems with nuclear energy. Well, I hope that was helpful in helping you understand the different types of non-renewable energy in the world and who uses it and where they're coming from.